Okay, we're going to look at another video where we're just going to look at factoring some more examples of trinomials in this form, so where you have a number in front of the x squared. These ones are going to be a little bit more tricky. So the reason this one's a little more tricky than the last one is because of this term. So notice 6. So the first two terms here must multiply to give me 6. Well, here's why it's more trickier. It could be 6 and 1, or it could be 3 and 2. I don't know which one it is. So I'm going to have to try both. Well, if I get lucky, the one I try first will work, so I don't have to try both. So it's either 6 and 1 or 3 and 2. So now I'm going to list all the products of negative 10. So negative 10 and 1, or 10 and negative 1. 5 and negative 2, or negative 5 and 2. So I'm going to go 6 times negative 10, 1 times 1. If I add those together, so negative 60 and 1, it's negative 59. It's not negative 11, so that doesn't work. Now try the diagonal. 6 times 1 is 6, 1 times negative 10, negative 10. If I add those together, I get negative 4, so that pair does not work. Then try the same thing. I'm not going to go through each one. They're all not going to work. So that tells me that it's not 6 and 1. It tells me it must be 3x and 2x. So I tried the wrong pair first, which is a little annoying, but hey, it happens. So I'll just rewrite all these pairs. I mean, you don't really have to rewrite all these pairs if you didn't cross them all out. You don't have to rewrite them. I just did that to illustrate it. I would recommend not crossing them all out. It saves you some writing. So now we're just going to try all these ones again. So 3 times negative 10, 2 times 1, so negative 32. If I add those, I get negative 28. Doesn't give me the middle term. So now try diagonal. 3 times 1, 3. 2 times negative 2, negative 20. Doesn't add to give me negative 11. So it's not this one. And then keep going. So you'll notice this one won't work. Try this one. 3 times 5 is 15. 2 times negative 2 is negative 4. 15 plus negative 4 is positive 11. So that one didn't work, but it's just the opposite sign. When it's just the opposite sign, that should tell you just need to use the other numbers. So 3 times negative 5, the other sign. So 3 times negative 5, negative 15. 2 times 2, 4. So if I add those, I get negative 11. So it's 3 times negative 5, 2 times 2. So I want 3. The 3 here has to be multiplied by negative 5. So the negative 5 goes in the opposite bracket. And then the 2 goes in the remaining spot. And then if you expand that out, you should get back this. So, I mean, this happens. There was 2 possibilities. There could be more. There could be 3 or 4 possibilities. And with this one, there was 4 possibilities. There could be more. There could be 4 or 5 or 6. There could be tons. You just have to go through all the possibilities. And the more you practice these, the better you're going to get at them. So you'll get to this stage where you don't have to write down every one. And that'll help a lot. So let's just do another one. So 8x squared minus 16x plus 6. So you're gonna, think of all the numbers that multiply to 8, and there's a lot of combinations, right? 4 times 2, 8 times 1, well, it's just the 2 combinations, and then all the ones that multiply to 6. One thing I'm going to warn you about is you might notice that there's actually something you can do first. There's a common factor of 2. So every term is divisible by 2. They're all even numbers. So you get 4x squared minus 8x plus 3. And that's better, because now we have to look at this one, we have to factor this one. But the good thing here is there's fewer options. So it's going to be 2 brackets. So what multiplies to give you 4? 4 and 1, or 2 and 2. But then this one, it's 3 and 1. Although notice that the middle term is negative, so we need to add to a negative number. But since this is positive, they need to both be the same sign, so that should tell us they're both going to be negative. And then just try this. So 4 times negative 3, it's negative 12. 1 times negative 1, negative 1. Add those. Doesn't give me negative 8. Go diagonal. 4 times negative 1, negative 4. Negative 3, negative. So it's not this one. So hopefully it's this one. 2 times negative 3 is negative 6. 2 times negative 1 is negative 2. Negative 6 plus negative 2 is negative 8. So this is it. 2 times negative 3. So it's 2x and 2x. I want to multiply 2x by negative 3. So put it, well, they're both 2x, but opposite bracket and then minus 1. And then you could expand this to just make sure you get back this. And the reason we common factor first in this case is it's a lot easier to factor this than it would have been to factor this. Because in this case, you would have had more possibilities. Right? In this one, 3, we knew it was negative 3 and negative 1. But if it was 6, it could be 3 and 2 or 6 and 1. So we'd have more combinations of numbers. So by common factoring, we save ourselves some of the possibilities, which makes it a little bit easier. And then another thing I want to show you is I could give you trinomials plus, I don't know, trinomials that don't factor, at least don't factor over the integers, which means there are no integer numbers which will work. So let's say you tried this one. Okay, 2. I know the first term's 2 and 1. It's got to be 2x and 1x. And then the last term, 1, well, 1 and 1. So if I try multiplying, so this is good, there's only a couple options. There's only one option really. So if I did 2 times 1, I get 2. 1 times 1, I get 1. 2 plus 1 is 3. It's not 5. It doesn't work. 2 times 1 is 1. 1 times 1 is 1. Again, doesn't add to 1. So this one doesn't work. There's no numbers I could put here which will make these binomials multiply to give me that. So this one we would say not factorable. And technically we'd say over the integers. There are numbers which will work, and there's always numbers that'll work, but they might not be, like they might be square root numbers, or actually some numbers we haven't learned which could be called what we call imaginary numbers. So in this case, if there's no whole numbers or negative numbers, integers, then we would just say not factorable over the integers. One thing I'll warn you about, and this happens a lot, is now that you know some aren't factorable, don't assume everyone is not factorable. Right? Most of the questions you see will be factorable. If you try them all and they don't work, I'd recommend trying them again. And if they still don't work, then maybe write not factorable. Don't start with not factorable. Okay? If you're given a quiz or a test, you're not going to see more than 1 or 2 that are not factorable. If you have like 10 of 12 that you say are not factorable, you're probably just not factoring correctly. So don't stick to this one sort of as your default. So sometimes they're not factorable, but don't assume they're all not factorable.